So a lot of people learn the greenhouse effect visually. So the greenhouse effect, the main idea is that the sun's light, which we call insolation, comes into Earth as a short wavelength because most of it is visible light. As that light hits the Earth's surface, it heats the Earth's surface. At nighttime, when the sun goes down, it kind of cools off outside, and that heat from the Earth's surface then begins to try to escape out into space. What we call heat as an electromagnetic wave, or its wavelength, it's a long wavelength called infrared. So when you hear the word infrared, you should think heat, which is an invisible wavelength, but you can feel it. So as that infrared tries to escape out into space, it gets trapped. Just like how heat gets trapped inside the glass of a greenhouse, the heat gets trapped inside of greenhouse gases, which are carbon dioxide, methane, and water vapor. These make up less than 1% of the Earth's atmosphere, but they are the majority of the reason why the Earth's atmosphere is the temperature that it is. The rest of the Earth's atmosphere is mostly nitrogen, which is the number one most, and then oxygen, which aren't very good at trapping heat, so they do not cause the greenhouse effect. So let's draw it out. Here is the Earth's surface, okay? So there's the Earth's surface, and there I am, enjoying the heat from the sun, okay? So here's the sun. I'm gonna make it red. Remember, the sun is actually a white, yellowy star. And what I'm going to do is draw the majority of the wavelength that comes from the sun, which is a short wavelength. So there's the short wavelength. And it's not just one wave, it's tons and tons of waves, right? And it's not just a visible light, it's also some infrared and ultraviolet. But we're just going to call this short wavelength. Okay, which is mostly visible light. Okay, so mostly visible light from the sun. So I'm taking that in, that's nice, getting a little tan from that ultraviolet, but not too much because it's not good. All right, but then at nighttime, once it cools off, the Earth's surface has absorbed the heat during the day, or absorbed that short wavelength during the day. And when we absorb light, just like how when you stand in front of the sun, you absorb the light, you get warm. So the Earth's surface heats up. So the Earth's surface heats up, okay? Now, remember, what is the wavelength for heat? It's infrared. It's a long wavelength. So this heat now tries to escape back out into space. And some of it does. It goes all the way to space. So it escapes all the way out into space. But we have these things called greenhouse gases. And these greenhouse gases absorb heat. So these things absorb heat. And they absorb heat really, really well. So they absorb heat really, really well. What are the three greenhouse gases? There's carbon dioxide, there is water vapor, and we got to include vapor. So water vapor, and there's also methane. Carbon dioxide is released by greenhouse gases in high amounts. Same with volcanoes, but we're focusing on the greenhouse gases released by fossil fuels. So that's carbon dioxide. And then methane is mostly released by cow farts. And there's also just like bacteria that break down different things. They also release methane. And water vapor just evaporates into the air. But the amount of water vapor in the air is related to the temperature outside. So the more carbon dioxide that's in the air, the hotter it is, which makes water evaporate more, adding more water vapor in the air, which is like this, double punch of the amount of greenhouse gases. So these are the greenhouse gases. And what happens is the heat that tries to escape out into space gets trapped. So there's the escape. Oh, it got caught. The infrared is trying to escape. So this is our long wavelength infrared. trying to escape back out into space. But it can't because the heat is trapped by greenhouse gases. By greenhouse gases. Just to be clear, an issue that I hear a lot from students is that the infrared makes the greenhouse gases. That does not happen. The greenhouse gases are in the atmosphere. And by burning fossil fuels, we're putting more greenhouse gases into the atmosphere, causing more of a chance for this infrared that wants to go out into space, or this heat that wants to go out into space, to get trapped by these gases. Okay? So these gases are just out there, and they trap infrared. So just to go over this, the sun, or insolation, produces a short wavelength that makes it to the Earth's surface and gets absorbed by the Earth's surface, which heats up the Earth's surface. So that's the short visible light wavelength gets absorbed by the Earth's surface. As that heat tries to escape out into space, or as that infrared tries to escape out into space, some of it makes it into space. But these three greenhouse gases, carbon dioxide, water vapor, and methane, are there, and they trap the heat, causing the heat to not be able to escape and to stay on the Earth. And sometimes they'll even send it back down to the Earth's surface as heat, causing it to just kind of bounce back and forth. All right? So that's the greenhouse effect drawn out.